When thinking about the human digestive system, we picture a static, passive tube waiting for food. In reality, your gut operates like a highly calibrated automated facility, and its schedule is strictly synchronized to the rising and setting of the sun. The opening and closing times for every organ are governed by a built-in biological clock, a master timing mechanism known as the suprachiasmatic nucleus, or SCN. This diagram shows the SCN detecting daylight through the eyes. It sends a cascading wave of chemical signals downward, waking the digestive tract. Morning cortisol surges, represented by this rising line graph, lighting up the organs for the day's heavy lifting. By setting a central schedule, the body ensures digestion begins when cellular machinery is fully awake, fully powered, and perfectly prepared to process raw materials. During this daytime shift, your system runs at peak efficiency. The pancreas pumps out digestive enzymes, and the transport systems along your intestinal walls are fully primed to absorb nutrients. At the same time, your insulin signaling works flawlessly. As carbohydrates enter the bloodstream, insulin signals the tissues to absorb the glucose, channeling it directly into the energy engines of the cells. Because the body's entire metabolic workforce is deployed and active, even the heavy load of a large midday meal is handled with ease. The energy is processed smoothly at high speed, with zero backlog. During daylight hours, the timing of your meals perfectly matches the mechanical capacity of your biology. The system takes exactly what it needs and leaves nothing to waste. But as the sun sets, the master clock issues a new directive. Sleep hormones like melatonin rise, metabolism naturally drops, and the digestive facility intentionally grinds to a halt. It transitions into nighttime maintenance mode. The biological conflict begins when we eat late at night. Consuming a large meal after dark forces a massive, unscheduled delivery onto a factory floor that has already been powered down. This dual clock diagram maps out the problem. The gut relies on a secondary timer called the food entrainable oscillator, expecting food during the day. When late-night food arrives, the gut violently snaps into active mode, creating a glaring synchronization error with the sleeping brain. Because the main processing systems are slow and insulin sensitivity is severely suppressed, incoming fuel bypasses the main processing engine entirely. Unable to burn the fuel, the body is forced to stash those calories in expanding fat reserves. By ignoring the biological clock, late-night eating overwhelms the limited nighttime workforce, turning what should be a routine digestive process into severe metabolic strain. The damage extends all the way down to the microscopic level. Inside your gut lives the microbiota, trillions of beneficial bacteria that act as your overnight maintenance crew. When you finish eating during the day, these microbes spend their uninterrupted night shift producing short-chain fatty acids. These healing, lubricating molecules physically repair and reinforce the walls of your intestinal tract. But forcing the gut to digest a late-night meal cancels that maintenance shift. The beneficial microbes stop working, and darker, inflammatory microbes aggressively multiply to take their place. This harmful imbalance is called dysbiosis. Deprived of their nightly repair cycle, the cells lining your intestines begin to degrade. The mortar holding the bricks together starts to wear thin. Your body relies on that uninterrupted nighttime rest for structural integrity. Without it, the physical barriers of your digestive facility simply begin to crumble from neglect. Once the intestinal walls weaken, the problem escapes the gut and enters the rest of the body. Hazardous bacterial waste, normally locked safely inside the intestines, now has a way out. Here in this cross-section diagram, we see exactly what happens. Toxic molecules from the outer shells of bad bacteria, known as lipopolysaccharides or LPS, begin slipping through the cracks of the degraded wall and dropping directly into your bloodstream. As the toxins flow into circulation, immune sensors called TLR4 detect the breach. They immediately trigger a cascading alarm system known as NF-kappa B, flooding the bloodstream with emergency inflammatory chemicals. If you eat late occasionally, the alarms eventually shut off, but a chronic habit of late-night eating keeps these sensors firing indefinitely. The immune system becomes trapped in a state of constant, low-grade inflammation. What begins as a simple scheduling error at the dinner table cascades into a system-wide immune crisis. Over time, that constant alarm drives insulin resistance and lays the groundwork for chronic metabolic failure. Restoring order to this system requires aligning our food intake with the body's natural operational hours. This approach is called time-restricted eating. It means limiting all of your daily calories to a consistent daytime window, usually 8 to 12 hours, when the metabolic machinery is actually turned on. By cutting off food intake well before sunset, time-restricted eating guarantees the facility a peaceful, uninterrupted night shift. Bathed in cool blue light, microbial maintenance crews can finally clean the floors, stabilize internal clocks, and rebuild the structural beams of the gut barrier. As the schedule normalizes, the biological benefits multiply. Systemic inflammation drops, insulin sensitivity returns, and the body regains its flexibility to effortlessly switch between burning carbohydrates and burning stored fat for fuel. Metabolic stability is built on two pillars: the quality of our nutrition and the timing of the intake. By respecting the biological schedule of our internal machinery, we protect the facility from the damage of unscheduled processing.